Okay, I'd like you to figure out if you still have your square card or not, the index card that you copied this on earlier this year. If you have not, you need to copy this onto one or just a sheet of paper. It's going to be very handy for this particular lesson. All right, so if you're using your square card, actually, you don't even need it. Hopefully, you don't need it for this. If we work inside the parentheses, the square root of 16 is 4. And if you use your square card, 4, so find 4 along here, go over to the cube column, 4 to the third is 64. So evaluate means we're finding the final answer that represents each of these situations. The cube root of 8 is how you read this. So go to the cube column, find the cube column, find 8, and you go all the way over, it's 2. So that's kind of how you use that. So the cube root of 8 is 2, and then follow 2 over to the fourth column, 2 to the fourth is 16. We read this as the fifth root of 32. So the fifth root of 32 all the way over is also 2. And 2, keeping the exponent on the outside, 2 to the third is 8. So this is leading us into rational exponents. This is all of our extra stuff. So we've been dealing with the exponents. Radicals can just be rewritten using exponents. Now, how do we read this particular symbol? This is the square root because if there's not a number here, the implied number is 2. We read this as the cubed root, the fourth root, the nth root. So when I rewrote this without the radical, where did the 2 move? To the denominator. We actually call this the index number. That moves to the denominator. So the cube root, if we rewrite without the radical, is a to the 1/3. The fourth root, rewritten as an exponent, a to the 1/4. So each time, if you're changing it, this is what we call radical form. And this side is what we call rational form. Because exponents are fractions, they're just ratios. This is the rational form, the radical form. So anytime you go from radical form, you take the index number and put it in the denominator of the exponent. All right, so if we're just rewriting, this is 4, take the index number to the 1/3. So every time you see a root, that means you need to use a fraction as an exponent. So you keep the base the same, change the root into a fractional exponent, move the corner number to the denominator, putting a 1 on top. Now let's go the other direction. If it's written with a fractional exponent, and we want to go into radical notation, you just create the radical, put the base underneath, and the denominator goes to the corner. Now you don't need the 2 that just implies square root. So if you see a fraction, you need to create a radical. The base goes underneath. The denominator goes to the corner. So notice we used all the same numbers. We just wrote it into a different format. You don't even have to find any answers. You're just rewriting it in these two examples. All right, so sometimes you have more exponents than just a 1. So what if it's not 1 over you still take the denominator to the corner, and you can either keep the numerator part of the exponent outside the whole thing. I would say this is how I write it. You could also write it as the nth root, keeping the a as the base, and that m could be on the inside. So it can either be the outside exponent to the whole thing or the inside exponent. Either one is acceptable. Now, what if it has both a fraction and it's negative? What is it when it's negative? What does that mean we do? You move it to the denominator. So I take the whole thing, move it to the denominator, make it positive, and then rewrite it as the nth root of a to the m power. So with numbers, it's actually a whole lot easier. So you keep the base the same. You keep the 2 in the exponent. Then you divide by 3. You're always moving the corner number to the denominator. So if it already has an exponent, keep the exponent. Just move the root to the denominator. Keep the base. Keep the exponent. Move the root to the denominator. Now let's go backwards. Radical notation. So change your exponent to a radical. Keep the 5. Take the denominator to the corner. And you can either take the whole thing to the 3rd power, or you can put the exponent inside with the 5. All right. Keep the base, change to a radical, move the denominator to the corner, either raise the whole thing to the 5th power, or you can just raise the 2 to the 5th power on the inside. Either one of those is the same thing. So then we use that so we can evaluate. Everything is always leading us towards finding answers, but we first have to make sure you know how to rewrite it so you can evaluate it. So it's always easiest to evaluate in radical notation. So if you see the exponent is a fraction, rewrite as a radical, keep the 9, put the 2 in the corner. Evaluating is always easiest if you keep the numerator on the outside exponent, because this just says what's the square root of 9, 3, and order of operations, we're just doing what's inside the parentheses first. 3 to the 3rd equals 27. All right, the first thing I would deal with in letter B, it's a negative exponent. So let's make it positive by moving the whole thing to the denominator. Now rewrite using radicals. Move the denominator to the corner and put the numerator, the exponent, on the outside. Now, the fifth root of 32, using your square card, you can see is 2, keeping the 2 in the exponent, and 2 squared is 4. This one's pretty straightforward. It's literally the fourth root of 625. So go to the fourth column, go down and find 625. It's 5. Do what's inside the parentheses first. The cube root of negative 27 is negative 3. Negative 3 squared is 9.